Hi, my name is Raiza Fronda. Today, I'm going to discuss about radiation and propagation of waves. But before we learn about this, we should make sure that we have some basic understanding about the meaning of radiation and propagation of waves. I know some of us already heard about this. Maybe it is because of technologies or even gadgets.
So, what is radiation? In physics, radiation is the emission or transmission of energy in the form of waves or particles through space or through a material medium. Radiation is energy that travels and spread out as it goes. The visible light that comes from a lamp in your house and the radio waves that come from a radio station are two types of electromagnetic radiation. The other types of these are microwaves, infrared, visible light, ultraviolet, X-rays, and gamma radiation. Now, let's proceed in propagation waves. Wave propagation is any of the ways in which travel with respect to the direction of the oscillation relative to the propagation direction. We can distinguish between longitudinal wave and transverse waves. For electromagnetic waves, propagation may occur in a vacuum as well as in a material medium. In a vacuum, electromagnetic waves travel at the speed of light, commonly denoted c. In homogeneous, isotropic media, the oscillator of the two fields are perpendicular to each other and perpendicular to the direction of energy and wave propagation, forming a transverse wave. Now, let's move on to the optical properties of radio waves. These are refraction, reflection, diffraction, and interference. What are the differences of the four optical properties of radio waves? First, let's talk about refraction. The classic case for refraction occurs at the boundary of two media. At the boundary, some of the electromagnetic waves will be reflected and some will enter the new medium and be refracted. In simple words, refraction is bending or it is a change of direction that light undergoes when it enters a medium with a different density from the one through which it has been traveling. Refraction could be defined as the bending of waves. Second is reflection. When a radio wave, or in fact any electromagnetic wave, encounters a change in medium, some or all of it may propagate into a new medium and remainder is reflected. The part that enters the new medium is called transmitted wave, and the other is the reflected wave. Reflection could be defined as bouncing of waves when they hit a surface. Third is diffraction. As radio waves undergo diffraction, means that a signal from a transmitter may be received from a transmitter even though it may be shaded by a large object between them. This states that each point of a spherical wave front can be considered as a source of a secondary wave front. Diffraction could also be defined as the scattering of waves. Last is interference, also defined as colliding. Interference occurs when unwanted radio frequency signals disrupt the use of your television, radio, or cordless telephone. Interference may prevent reception altogether, may cause only a temporary loss of signal, or may affect the quality of the sound or picture produced by your equipment. Now, let's move on in radio wave propagation modes. Radio propagation, or the way in which radio signals travel, can be an interesting topic to study. Radio propagation is a particularly important topic for any radio communication system. The radio propagation will depend on many factors, and the choice of the radio frequency will determine many aspects of radio propagation for the radio communication system. What is a radio wave propagation modes? Radio signals can travel over vast distances. However, radio signals are affected by the medium in which they travel, and this can affect the radio propagation. And this also affects the distances over which signals can propagate. Some radio signals can travel or propagate around the globe, where the other radio signals may only propagate over much shorter distances. Radio propagation is the way radio waves travel or propagate when they are transmitted from one point to another and affected by the medium in which they travel, and in particular the way they propagate around the Earth in various parts of the atmosphere. It can propagate from transmitter to receiver in four ways: through ground waves, sky waves, free space waves, and other field waves. Ground waves exist only for vertical polarization produced by vertical antennas when the transmitting and receiving antennas are close to the surface of the Earth. What are the different radio waves and propagation? The mode of propagation of electromagnetic waves in the atmosphere and in free space can be divided into the following three categories: the line of sight propagation, ground wave propagation, and sky wave propagation. There are many factors that affect the way in which radio signals or radio waves propagate. These are determined by the medium through which the radio waves travel and the various objects that may appear in the path. The properties of the path by which the radio signals will propagate governs the level and quality of the received signals. Refraction, reflection, diffraction, interference may occur. The resultant radio signal may also be a combination of several signals that have traveled by different paths. These may add together or subtract from one another, and in addition to this, the signals traveling via different paths may be delayed, causing distorting of the resultant signal. It is therefore very important to know the likely radio propagation characteristics that are likely to occur. There are many radio propagation scenarios in real life. Often signals may travel by several means. Radio waves traveling using one type of radio propagation interacting with another. However, to build up an understanding of how a radio signal reaches a receiver, it is necessary to have a good understanding of all possible methods of radio propagation. By understanding this, the interaction can be better understood along with the performance of any radio communication system that are used.